Namaskar. I'm Harpreet Kaur and I welcome you all to our live and interactive session. You are watching us on PME Vidya channels from 6 to 12 and also on our YouTube channel NCERT Official. Well, this is our online training session under the umbrella theme of ICT for Teaching and Learning of Science. And now, I have to say that this is a training program, which means that you can participate in the assessment and you can also get a certificate. But what is the procedure that you already know? But since we are in day 3 of the session, today's topic that we have taken up under the umbrella theme is FOSS for the Teaching and Learning of Science. Now, what is FOSS and how it's an important tool when it comes to teaching and learning of complex calculations and complex concepts of sciences? This session is live and interactive, so you can always give us a call. Our phone number is 8800440559. We also have a dedicated email ID for you, and that is training.helpdesk@ciet.nic.in. Last but not the least, you can also put in your questions, comments and suggestions in the comment section of our YouTube channel NCERT Official. And we all know that ICT is playing an important role when it comes to teaching and learning of any subject, be it sciences, mathematics, languages. We're talking about AR, augmented reality, virtual reality, of course, virtual labs. But since this training program is strictly based on sciences, we can say that the use of ICT enhances creative and critical thinking among students. To know more about the subject, we have our expert with us. So let me introduce him to all of you. We are joined by Mr. Burjan Ji. Sir, namaskar and welcome to the session. Yes, so
from Government Boys Higher Secondary School.
Absolutely. I was about to, sir, introduce you completely. You are, of course, a guest for the day for this session, and you are a postgraduate teacher from Government Boys Higher Secondary School from Sailgudi, Tamil Nadu. And sir, please, you will, of course, cover the entire topic by way of your presentation. And also, we have some important questions that I'll be taking up at the end. But before we start the actual presentation and go into the details of the subject, I request you to kindly give us a glimpse of what we are going to cover in today's session. What is this FOSS and how it is playing an indispensable role in the teaching and learning of sciences?
Okay, good evening to everyone. FOSS means Free and Open Source Software. Science is a subject which contains a lot of abstract things. Abstract things can't be easily understood by the students.
Yes.
So we need some softwares to explain that abstract things. These softwares are available both in paid version and free version. So the free version of the software is called Free and Open Source Software. So FOSS means Free and Open Source Software.
Right.
The key characteristics of the FOSS is freedom to use, study, modify and share. To take some software, proprietary software, we have to purchase and we can't able to modify that. If you take some operating system, proprietary operating system, we cannot able to change. But open source operating systems such as Linux, we can get the source code. If you know the proper knowledge of software, then we can modify, reuse, and according to our school, we can modify that software and reuse that. That type of the softwares are called free and open source software. If you take example FET is a free and open source tool that can be used to teach science. That is created in terms of English. If you want to teach in Hindi, you can modify, you can get the source code and modify according to your language and make them to use in your place as you need it. So that kind of freedom is available in open source software. So also it is transparent collaborative development because our proprietary softwares are prepared by some people. We can't able to change it, but the a free and open source software, we can collaboratively work with them and modify and reuse it. It is cost effective and customizable for learning needs. Different geographical location and economic background. For example, if a student is learning from a remote area, we can't able to purchase a proprietary software and learn, because
Yes.
if it is a economically high background, the student can purchase and learn things. But the education means it should reach all the people irrespective of the geographical location and the economical backgrounds. So such free and open source softwares are available for all the users. So we should promote FOSS, and in this training session we are dealing with what are FOSS, and I am introducing some of the free and open source software that can be used to teach science one by one. So
Right.
first, before going to that topic, why we need FOSS tools to teach science? Because enhanced visualization of concept is needed to learn science. Because if you read a line, a man is riding on a horse, immediately your brain will think that there is a horse, a man is riding on the horse.
Yes.
But if you when you read, when a ray of light is passing through the lens, what happens? Your brain will not think anything if you don't understand, because it is an abstract thing. That is a real thing. So visually, if he can visualize the concept, he can easily understand. So that's only some stories can be easily understand, and they can recreate with another format. Because if when they are reading story, all the concepts are in the brain as a visualized thing. But while learning science, such kind of visualization is not there. So we have to bring such visualization into the minds of the children.
Right.
That
And,
can be possible using
yes.
this software. So
Absolutely,
enhanced
sir.
visual.
Here I will interrupt you a bit, because you are right. As you talked about some abstract concepts, like we don't know where the current is passing through and how it is passing through, about the radiations if we are doing some experiment like X-rays and all. So we kind of just visualize them in our minds. We don't really understand
Yes,
how
yes.
the phenomena is taking place. But through,
Yes.
of course, science and through these technologies, of course, they become so immersive and engaging in nature that you recollect them, you remember them for a long period of time.
Yes, that
Yeah.
is correct. You are very correct.
Yeah.
That's only if we are using this kind of software.
Yes.
So next one, I will demonstrate one or two tools after this introduction. First, I am give brief idea about these FOSS tools.
Yes.
Interactive learning. Interactive learning is possible for this. For example, if you go in a lab and find the resistance of a copper wire, you can do it in the lab. But if you want to change what happens when the radius of the wire is changes, for if you increase the radius of the wire, what happens to the resistance, that you can't do it in the lab. If it is a virtual online lab, this can be possible. So by giving some input, you can get immediate output. So interactive learning is possible for this using these ICT tools. Then real-time data. Whenever you give the data, you will get the output. For example, you construct a circuit and you want to change the value of the resistance. If you change it, immediately the value changes, current changes, voltage changes. Therefore, access to real-time data is very much can be done using these tools. Also, encouraging inquiry-based learning. Inquiry-based learning is learning through questioning. So, the real learning occurs only through inquiry. So, whenever a student is reading something, some question may arise in the mind of the children. Most of the children are not ready to ask towards the teacher directly because of the classroom environment and different environment. But when they are doing such a learning through these ICT tools, immediately they can inquire through these tools and they can clarify their doubts without any hesitation. Therefore, encouraging inquiry-based learning is done here. Then collaboration and communication. We can collaborate and do the experiment. And also accessibility and inclusivity. All kind of people can be reached in somewhere else. If there is some visual problem for the child, then they can hear through the ear. Such ICT resources are available here. So all type of accessibility and inclusivity is available.
True.
So, okay. And now I am telling some of the categories of science ICT tools. So I already told that ICT tools are very much used for visualization.
Absolutely.
Now here I am sharing some categories of science ICT tools.
Okay.
Simulation software. This is an important category. So example, FET and P-table. FET already you know, it is a simulation tool that can be used to teach physics, maths, biology, and especially it is for physics. P-table is another tool which is used for chemistry. So many tools are there. I am introducing a few tools which can be used freely.
Okay.
That's the topic of our
the discussion today.
Today's topic.
Yeah.
Yes. Then another one is virtual laboratories. The real, actually, the science should be done in real laboratories, but virtual laboratory we need because of some devices are not available in our labs, and also we can change the variables in different senses that can't be done in the real lab. For example,
that is the best part of virtual laboratories, that you have a control over the variables.
Yes, variables. If you want to find out the refractive index of some material, you can easily change the material, water, air, etc. But in real lab, it is difficult to. So, virtual labs are very much in. OLab is one of the best virtual lab, which is open source, and also VLab, virtual lab by Amirda. That is also a very good lab in today's world. Then AR and VR is another category of ICT tools. The augmented reality and virtual reality. So GeoGebra 3D is an open source augmented reality app. Because now look at this video. Here is a ball on the table. It is in the real world. Through the AR GeoGebra app, I am creating a ball like that. So through that app, it will looks like it is on the table. So really I construct that ball inside the app of GeoGebra 3D, but we can make them we can insert these files in a real world. That kind of reality is called augmented reality. But the surrounding is not going to change. We are keeping some pictures and other things on that surrounding, so that we will get a better learning experience. So we can, for example, if you want to move an object and find the velocity of the ball on the table, so you have to construct a ball in the GeoGebra app and move it in the app, and through this AR app we can easily find out the velocity. So this kind of thing can be done in augmented reality. Virtual reality means we are changing the reality. For example, in virtual reality, something is done to visualize Mars. That means we can go and by walking on the Mars itself, we can see the things. So the difference between these two is, in augmented reality, the environment is not changing. We are inserting some pictures or some interactive on the environment, so that something is moving or interacting on the environment. Virtual reality is completely, it is virtual. It is, we are changing the reality. So for that we need some external hardware and software for VR. For AR, we just need some software alone. So for AR, many proprietary, that is paid softwares are available, but free software, this kind of 3D, GeoGebra 3D, such kind of AR tools are available, and it is an many. I hope many tools will come free in the future. Similarly, for VR, our NCERT is also developing some VR resources for learning. It is available in CIT. That will be spread throughout India very soon. In mobile, 3D anatomy is an app which is a VR app. So these are AR and VR app. Next one is planetarium software. So planetarium software is also very needed for our life. From some 6 months back, I explained this Star Walk app to a student.
Okay.
From the next day itself, he watch every day. He take his mobile and watch the sky in the every day, and he found that some new planets are coming, and how the planets are changing place to place every day. Such kind of activity is going on to that students.
True.
So Star Walk is a best tool to watch the planets and distance or etc. So if you make them to use in their home, because every people have mobile in their home, most of them have.
Yes.
So if they use to observe stars and different planets from their home, they can become very good in astronomy.
Yeah.
They can learn practically astronomy instead of learning some without any visualization. They can, because if they watch regularly, then there is a they also create some pattern, new pattern they can create. So scientist kind of thing will develop among young child if you use this one. Then molecular modeling software. If you take chemistry, molecules are the main things, but we cannot able to visualize molecules. But if you know the structure of the molecule, how it becomes. Water molecule, we know that H2O, but how it looks like. What is the angle between hydrogen and oxygen? That is that if we know that, then we can make research on that topic even in the small children. So molecular modeling is very much important for chemistry. Avogadro and Workbench are some of the free tools that can be used as an ICT tools. So an online repository, many online repositories are there. Khan Academy is a free online repository. All kind of videos, all in all subject it is available. Liberate Text, this is also one of the best online repositories for different subject. So these are some of the different categories of tools that is available freely on the internet. So just I told what is the need for ICT tools. Then some of the categories of science ICT tools now. Now let us go some one by one, some tools one by one.
Sure.
FET is one of the tool which can be useful for students to visualize.
Okay.
It is better, instead of going presentation, I can go by demonstration. If you go to Google and if you type FET, you will get this link. You will get this link. Here simulation is there. Physics, maths, chemistry, different subjects are there. If you click physics, then the simulation which related to physics will be displayed here. And also they can categorize the subject. If you remove all the subject and click motion, all the motion related things are displayed here. So sound and different subjects are there. So I will demonstrate one or two application here. First, I will take some energy conservation for small classes. So if you take a iron and water, So here energy symbol is there. You can link the heat is here. So normally when you heat water, energy is converted in different forms. But we can visualize here because now look at this. If you heat this one, some heat energy is raised, and it will come one by one. It comes fast in iron. That means a specific heat capacity of, when we compare specific heat capacity of water and iron, iron has less specific heat capacity. In this way, we can teach whatever you want in this change of state. Also, they can visualize that. If you click that system, the same energy and forms the changes. Now I increase the speed of the cycle, energy symbol. Now these different colors are mentioning different energies. Here mechanical energy, this mechanical energy is converted into heat energy. If I replace this by bulb, this mechanical energy is converted into, it is yellow color. It will come as yellow color. Now look at this yellow color and red color. That means thermal energy and light. It is coming out, thermal energy and coming out. If I keep the solar, then if you can put some, so if you increase the cloud also, we can adjust the energy. So different forms of energy can be easily explained using this app. So only main advantage is you can visualize things. That is the, so after seeing this and go through, while the child is reading the book, when light is passed through the bulb, when electricity is passed through the bulb, light energy and heat energy are liberated. When one child reading these lines, automatically its brain thinking like this picture will come in his mind. So more understanding, more visualization, more understanding means they can ask more question. More question, if they ask, then learning will be enhanced.
Yes.
So such type of learning will come through this. So if you, I will take another example. This is light. So when I on the light, so if I can move this, angle of incidence is here, it is 30 degree. So angle of reflection is also 30 degree. So this is first law. Angle of incidence is equal to angle of reflection. So if a teacher teach, instead of drawing on the board, if he use this, he can. Another thing is, now when a light is incident on a glass, everybody think that the light gets refracted, and that is light will go into the glass. But the real is only, now I will check the intensity. Here it is, intensity is 100. That means 100% of light is coming. Now I will check it here. 95.26% of the light is refracted, and this 5%, 4.74% of light is reflected. Wherever a glass surface is there, a small part of the light is reflected. But we can't able to visualize that. In lab also, if you do the practical, we will get only refraction. This reflected, you can't see this because the intensity is very small. So such minute things can be taught using this ICT tool. That is the advantage of using these kind of ICT tools. Another thing is, if I change this medium, for example, if it is a air medium, and since both medium are air to air, there is no deviation. If I change it to water, some deviations are there. In glass, in light, there is one demonstration called total internal reflection. That means here both reflection and refraction are takes place. So particular angle, above some particular angle of incidence, only reflection takes place. Now look at this. Here both are takes place. I increase the angle. around 48 degree, around 48 degree. No, this is air and I will take this glass. So this is glass, around, this is 30 degree and around 42 degree, I think. So 42 degree. The total no. Here the problem is the light should pass from a denser medium to rarer medium. I am keeping this rarer medium to denser medium. Therefore, I have to keep here glass and here air. That means light from denser medium to rarer. Denser means density is greater. So now I will do the experiment. I am increasing little bit lit. This is 30. Both reflection and refraction are there, and around this is 40. Both reflection and refraction are there. Now after 42 degree, lights, all the lights gets reflected. So 100% of the light. After that, if you change any angle, the light is not refracted, it is reflected. So these minute things can be explained in the classroom, but can't be visualized.
Yes.
Yeah, that is the beauty of this.
True.
So another thing is, this is a circuit. You can create this if you take physics and taking electricity and magnetism, construction of circuit DC, and you will get a blank surface like this. You keep a light, battery, and connect this light with the battery, it will glow. So simple electric circuit. So if you increase the voltage, what happens? This is sample only I show. Now I construct, in the similar way, I constructed two circuits. Now look at this. When I on the board, close the circuit, there is a light glow. Now this is, so which one is brighter? So what happens when two lights are connected in series? What happens when two lights are connected in parallel? What is the difference? So these kind of things can be done in the lab, but this kind of visualization can't be achieved there. That is the thing I want to say. Another thing is, if you show this on the board, you are teaching something. That means it is completely teacher-centered. You are explaining something in terms of, it will be helpful for teacher only.
Okay.
Now, what can we do for learning? Look at this table. Instead of demonstrating, after demonstrating, I give this table. Now, serial number, voltage, current, bulb 1, bulb 2, bulb 3, bulb 1 and bulb 2. So I will ask some question. Why do you think the bulbs in the parallel circuits are brighter than those in the series circuit? How does the voltage behaves in series circuit compared to the parallel circuit? How does the current behaves in a series circuit compared to a parallel circuit? So, such question, if I asked and give this worksheet to the students, then automatically they will answer and they will inquire this to the here. For example, they can adjust the resistance, value of the resistance, they can adjust the value of the battery. So different things are available. According to this, if you create some worksheet and give it to the students, then it will become student-centered. That is learning. So if a teacher wants, our topic is free and open source software for teaching and learning.
Yes.
If you want teaching, then you have to demonstrate it. If you want learning, then you have to create worksheet for everything. So whatever I showed to you, then you have to create a worksheet like this I shown. So like this, you have to create some worksheet and give to the students, and they will do the experiment or do the simulation and note down the take the data, and they will come to a result. In such a way, if they learn, the learning will be very great, and also visualization is very nice. So that is the thing I want to say. So another one is a stellarium. So I already told to seek space. I showed two examples. One is stellarium and another one is Starwalk. Stellarium is an open source tool. If you type it here, for example, if you type one object, moon, then the moon will come. So every day, here some dates are there. Now, if you click it at the bottom, this is available both in offline and online. Online, if you type in Google Stellarium, it will come automatically. Offline, that means you have to install it. If you click this time and you change the time, for example, now it is the time is changed, but you can change the time and our date now today 18 or 24 date is 18 19 what happens 20 what happens now if you change the date automatically the position of the moon gets changed. Did you notice that?
Yes,
you can change the position of the notice. So you can't able to teach the movement of the moon. For example, in 15 days it will change its face.
Yes.
So that can be done through this app. Another one is you can show some solar eclipse, lunar eclipse, etc. For example, I will show one picture here. Activity. Now look at this. This is 2019 12 26 12 2019. On that day, solar eclipse happened. So you adjust the time of any. If you know any date of the solar eclipse happened or to be happened. In future also solar eclipse there. So if you adjust the date and time here, you will get and also you can see the movement of the eclipse like that. That is another thing. So the time is very short, I think so. So I am going little fast because I have to introduce some tools that you can, if you know these kind of tools, you can automatically go through and learn by yourself. Yes. Nobody is needed to learn all these things. So another interesting tool is this P-table. Now look at this. This P-table has 4 tab: properties, electrons, isotopes, and compounds. Now if you click property, all the elements in the periodic table will be displayed here. Now the beauty is, if you click boron, the properties of boron will come. More than that, if here some temperature is there, if you increase the temperature, the property of the material changes according the color change. For example, solid this color, liquid this color, gas unknown. So if you increase the temperature, the what happens? All the melting point, boiling, all the properties are displayed here. So it is a very nice tool for a chemistry teacher to explain the different elements. Whenever they are introducing a element, he can come and he can view the different properties of the. So electronic configuration is one of the most difficult thing to understand, because the structure of the electronic, they will memorize this. So if I take helium, helium has different p orbital, sp orbital, d orbital. Each orbital have different shapes. So these shapes can be explained in 3D using this app. Very, very interesting. So if a child go through this site and learn little 1 or 2 times, they can easily visualize these kind of things.
Yes.
What is most of them, they don't know what is the difference between s orbital and p orbital. Just to come and learn for different elements how s orbital changes for different elements. So many questions will arise automatically in the child's mind. If they ask, no person is needed, just they will ask here by clicking here and there. They can ask their questions, so they can find the answer also. If you click that third tab, ISO tab, here if I go through the hydrogen and click it, all isotope will be coming here. Look at this, H1 to H1, so all possible isotopes are coming. When I click something, the property will be coming. So different types of isotopes can be learned from this. And another one is compound. Compound means if I click any element chromium, all compounds related, compounds that will come along with this chromium will be displayed here. If we click this, I will get the property uses, etc. So this is to learn elements and compounds. This is one of the best tool for a chemistry teacher, which is completely free.
Right. And so,
So
now we are left with very little time. So if there is another important tool that you would like to showcase, kindly do that, because we have some questions also. And that picture was very interesting of Leaning Tower of Pisa.
Yes.
Yeah.
I will stop after doing this.
Yeah.
For example, here this is on Vascock or physics in school like that, or physics animation. If you search in physics animation, you will get it. It is Vascock.cs tool. So everyone is explaining stability. Stability. Now, stability means the line drawn passing through the center of gravity should pass through the base. That is the idea that want to say. Now, I change this shape like this. Now, the center of gravity is inside the base. So, I change this. It is not till this point. It is not. So this is the principle of this Pisa tower. So if you draw, the center of gravity is in such a way that the line drawn through the center of gravity must pass through the base. If I change little outside, this is still in equilibrium. But if I increase little, yes, it fall down. So this is the idea of equilibrium. So if we show this kind of small animation is largely available in Vascock.
Right.
So if we go through, teacher can go through this Vascock, he can simple for small principle and concept, he can use that freely. That is the thing I want to say. I think you have to ask some question. I will explain some other tool if time permits. Otherwise, I can answer the questions.
So now, if you can just explain something else that is essential in 2 minutes, and that will be great, because we do not have more time than that. Yeah.
Okay. Now, this is OLabs. I already explained some of the simulation, but a lab is very much for students. If you go to OLabs in physics, chemistry, biology, all are available. So
these are virtual labs which you were talking about in the beginning.
Virtual labs. It is available physics, chemistry, biology also. I didn't say about anything about biology. So I just take this one, biology.
Sure.
And for lower class something is there.
Like we can have the process of photosynthesis, digestion.
Yes, all are there.
Respiration.
Yes. Photosynthesis means here it consists of 4 parts. Every OLab has like this theory. Theory, it will explain that about photosynthesis. Whatever thing it is explained. Then second one is procedure. What is the procedure to do the experiment?
Okay.
And the third one is animation. That is a video that will explain what is photosynthesis. And fourth one is simulator. This one only that we need. Because this, if you start here, some amount of carbon dioxide is generated, isn't it? In the photosynthesis process, carbon dioxide is liberated in the process. You can increase the intensity of light, power source, etc. Some amount of intensity of, we have to note on the time and how many bubbles are coming out of this due to this reaction. Using that, we can study the photosynthesis process. That is the one of the lab available. And also, if you study the pollen grain, if you take the pollen grain also, the same thing. Theory means the explain procedure, what you have to do for this lab activity. Then animation means a video will explain all these things.
Right.
So then simulation means you have to do the simulation. For example, you can.
So there are simulations available, and you can
Yes.
also get yourself assessed.
Yes, assessed. But you can keep the slide here and place this and view the. You can view these pollen grains. That is the procedure.
Right.
So similarly, for many experiments for class 10, 11, for class 12, many experiments are there. 11 experiments are there. For class 10 is then up from class 9 to 12. Many experiments are there. Most of the experiment that we are doing in the classroom can be explained here.
Through virtual labs.
You can do it in virtually.
Right.
Virtually, yes, virtual lab.
Now, sir, you have.
For example.
Yeah, you showed us so many tools, and you showed us so many free and open sources that are available when it comes to teaching, learning of sciences, and we have clearly, we have clearly figured out that these are not just learner centric but teacher centric also. So you can get the feedback assessment as well immediately. Also, these tools are important because we need to understand these abstract concepts, and that they are available and very beautifully explained through the help of these VR. And of course, we talk about AR, VR also. These technologies are so immersive and engaging that you can always remember the concepts, and you can learn a subject very joyfully, especially a subject like science.
Yes.
It develops your interest towards the subject and inclination towards performing more experiments. And I think science is all about experimentation. Unless and until you do that, you won't get a strong hang of the subject. But sir, I have few questions for you, as I was telling in the beginning, that there are challenges that teachers and schools generally face, while implementing simulations, particularly in under-resourced rural areas where, of course, there are dearth of opportunities, resources are not that available. So what are those challenges, and how can they overcome the same?
The main challenge is internet is the main challenges, because these tools are completely free. So tools that I am introducing today are completely free. You no need to pay anything.
Okay.
And the problem is you need internet. I am also from a remote place. I am afraid of this kind of, even though I have internet with high speed, but it is a hilly area. Anytime the internet may be disconnected.
Yes.
So such a situation is everywhere, but even there are remote places that we have no internet. So in that situation, it is some difficult for teacher to teach. At that time, some of the tools can be used as an offline. For example, I told many example in FET. If you type FET offline, offline, you will get offline access. Offline access means you have to download this. For Windows app and Mac app, there are links. If you click this Windows app, with your username and password, you can log in and you can download it. And if you install it in your computer, it will give an icon like this here, FET like this.
Yes.
So you can use it as an offline. So for teachers from rural area, download this offline simulation tools, then they can install it in their school computer, and they can use at any time. So nowadays, this is the possible solution. But in the future, everywhere internet will come freely, one by one. Government is also taking many initiative to take net in throughout India in all nook and corners. So in future, everyone can use. But nowadays, this is the main problem.
Yeah.
And this can be solved using this?
Absolutely, using ICT in science is quite cost effective, but then there are challenges and there are external factors that you generally can't control. But again, there is a silver lining in the dark clouds in terms of many software that are available offline and work well, work effectively.
Yes, yes.
But sir, you know, we are moving away from the traditional method of teaching, be it any subject, you know, we're focusing more on developing skills and enhancing the creativity and analytical thinking. So how do you think teachers can effectively manage simulations into their routine lesson plans when it comes to subjects like biology, physics and chemistry?
Okay, now the problem is how they can integrate this to their regular lesson plan, because these kind of in lesson plan, how they are teaching, that is the writing, they are writing what is going to happen in the classroom. So they can record this. For example, if one teacher wants to teach the first law of reflection in their class, he can record this, screen record by by changing this angle of reflection is not changing, or changing according to the angle of incidence. Therefore, angle of incidence is equal to angle of incidence. They can do this experiment and screen record it, and they can use as a teaching resources, because nowadays ICT using ICT tool is one of the main thing that is needed for their lesson plan. They can use this as a lesson plan. Also, they can add their voice along with this screen recorded things.
Well, that's lovely.
Students listening or watching the content with their class teacher's voice, it will get more motivated them to learn, because if they instead of hearing anybody's sound, if they are hearing their own teacher's voice, then it will be more interesting to learn by the students. So the teachers can add such things along with the they can screen record this kind of simulation, add their voice and make it as a video. That kind of skill they have to develop, and they can add these things too. And another thing is that they should know where to introduce this while writing lesson plan, where to introduce this. For example, if a teacher is doing this, the effective manner is taking them to the lab and doing the experiment is the real science learning. But while writing the lesson plan, he can add this as an introduction of the lesson. So in the initially, I will explain this virtual experiment in the classroom. After doing that, they will do it in the lab in such a way that they will add in the beginning of the lesson plan. Or they can add in the end of the lesson plan also, because after doing the experiment, some questions may are what happens when the resistance of the bulb increases. Such a question will arise in the mind of the child. So they can come there, they can't able to change the resistance of the bulb.
Absolutely.
But here they can do it, and so according to you, the way of writing the lesson plan, the teacher can add this kind of activity previously or end of the lesson plan or on the going process, as the teacher think how these can be included. In that way they can include in their lesson. Anyway, they have to include somewhere in that.
Somewhere, yes, because this is the whole motive, because we are talking about blended learning, and of course we have to cater to the needs of specially able children as well. And when we have the option, then why not?
Yes, because if they want to do this activity for some active children, they can be ended in the put in the end and ask them to do in the home. But if they want to do it, everybody should know, visualize what happens, then they can put it in the middle. Or in the learning process also they want to add, they can put in the middle of the lesson plan, such a way that they can do it in the class. So it all depends on the teachers thinking, but anyway they have to include it. That is the point I want to say.
And sir, you already made us understand that how these tools that we use, or these simulations make abstract scientific concepts really accessible and understandable to us. So I won't ask you this question again, but I will ask you that do you think that proprietary tools offer any significant advantages over FOSS, that is free and open sources, and if yes, then why? If no, then why? Answer, we have very little time left, so very quickly I request you to kindly answer it.
Okay. Now, the free tools we can almost, for example, if you want to explain this parallel series, if I connect this series with three, the car will get slow down. If that means if you imagine the same situation in terms of electron, if you connected in series of resistance, the flow of electron will less, then current flow will slow down. And that can be explained very easily. Similarly, when I add parallel, the current flow is large. So such an idea can be easily given to them using this app. It is a open source. It is from Java lab.
Yeah.
It is an open source. The same thing, it is not so much interactive.
Okay.
It is look like a demonstrative or a demonstrative purpose. The same idea, if it is some proprietary softwares are available, but you can adjust the variable, many parameters, and some self-learning material. Anyway, when compared with the free and open source, proprietary software has some advantages, and also they have great features.
Absolutely, sir.
But yeah, there is no doubt in that. But the free and open source is the only tool that has to be. The idea is to be spread everywhere, because education should go everywhere.
Education,
so we have to promote this FOSS and support those who are using FOSS and collaborate with those who are using FOSS.
Absolutely, sir. Absolutely. You're right, because we have to make education accessible to everybody. We have to make it available at students' doorstep. So, sir, thank you so much for your contribution to the session. It was wonderful indeed. We learned a lot about different open sources that are available. I'm sure that students and our viewers will take the advantage of what they have learned in the session and will use them for learning the concepts of science more effectively. Thank you once again.
Okay, thank you, ma'am.
So viewers, that was our session under the umbrella theme of ICT for teaching and learning of sciences, and today on day 3 we talked about FOSS for the teaching and learning of science. And now I'm closing this session over here, but before I leave, here is an important announcement regarding the upcoming competition. Yes, the All India Children's Educational E-Content Competition is back for the year 2024-25. We invite teachers, teacher educators, student and independent educational e-content creators to submit their best e-content for the competition. For further details and the registration form, you can visit the website www.ciet.ncert.gov.in. Visit the activities section of the same. You can also scan the QR code on the screen. The final date for submission is 31st of December 2024. So please send in your best content, and we wish you all the very best. May you come out with flying colors. And now let's take a look at the live schedule. Yes, these were the programs that we, of course, webcast or broadcast for you, and you can watch them again on different platforms. In a short while from now, you can watch our session Sahyog, where we will be talking about the role of gratitude. Yes, this is very important, and do tune in. And meanwhile, this is me, Harpreet Kaur, taking leave of you. But you stay tuned for more educational programs.